All right, hello, Aubrey, and maybe that's it. Okay, 1 through 4, all. That is the first and second page. So just one sheet for homework, and there it is. All right, we have two-way frequency tables. Two-way frequency tables, also called, if you want to write this down, you don't have to. They are also called contingency tables. I think that's kind of a fun word. Contingency tables, two-way frequency tables. So we have two things going on. You've seen a two-way frequency table already, like juniors and seniors, and then boys and girls, right? Yeah. Two things going on. We're trying to like match them up in a table. Okay, that is a contingency or two-way frequency table. Okay, here we go. They give us a table, and here's what we're talking about. We are talking about men versus women and showering in the morning and showering in the evening. Women like to do what? More women shower in the morning. More men shower in the...
I don't believe that. I shower. I disagree.
Who showers in the morning? Most often. Most often. Showers in the morning. Evening. Evening showers. We got more evenings, right? Okay. All right. Okay. I hope you sleep better, maybe. I don't know. Right? If you shower in the evening? Okay, whatever. 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 Okay. So, this is what this table has going on for us. Okay? Shh. All right. Everybody's here. All right. Here's some things that you need to write down. Listen. Listen, listen. Listen, listen. These inside 4 pieces of information. These are called joint frequencies or joint. Let's see. What are they called? Yeah, joint frequencies. Joint frequencies are the inside data, okay? The total row and column, these are called marginal. You need to write this down. Marginal frequencies. Okay? Joint frequencies are the ones that join together to make the table. The totals are the marginal frequencies. Have you heard of a margin of a piece of paper?
Yeah, it's the end.
Like the edge, the outer edge of a piece of paper, those are the margins, right? Marginal's the total, joint is the inside 4. Got it? Okay? They will use terminology on your homework assignment and say, find these joint frequencies. You're going to be like, what? Joint is the inside 4. It's like the meat and potatoes. The outside, the totals are the marginal frequencies. Got it? Joint, marginal, right? These guys join together to make the totals. Got it? Joint, marginal. All right. We surveyed 220 total people, yeah? Okay. And we surveyed more women than men. Probably just because they were there. Like, we're not trying to, like, cater toward the women, whatever. It's just whatever. Okay, there are too many side conversations going on. Be quiet. Shush. This will not take as long if you be quiet. Okay, here's my two-way frequency table. We want to do something called a relative frequency table, and relative means in relation to the other numbers, right? Relative, like you're in relation to your relatives, right? Okay, so in relationship to the total, I just am taking these numbers, 98, and I'm taking and dividing by the total number, all right? Here's what we're going to do when we create this table. This is not finished yet. We take each one of these joint frequencies, we divide by the total, and this, as a percentage, is how much?
22.
98 divided by 220. Somebody do it. You have a calculator. Everybody do it. 98 divided by 220. What percent? 45.0?
Stupid calculator.
44.5%. Let's go that. We'll go one decimal place beyond the percentage, okay? What about 37 over 22 or 220?
16.8.
16.8%. Okay? 135 over 220. Okay, you guys read my mind. 100% is this bottom one down here. 61.4%. 61.3.
No.
61.4 is what it rounds to. Okay, keep going. 23 over 220, 62 over 220. Pick one. What? 10.5%. Okay. What? 28.2. Okay.
121 over
'Kay.
220 is 55.
55%. Exactly. 55.0. Okay.
220 over 220 is 100.
I know. I got that one.
85.
80.
220 is 38.6.
38.6%. Okay. 99. And we got that one.
45 over
45 on the dot, 45.0. Okay. Perfect. There we go. There's what we have. Okay. That is in relationship to the those around it. Oh, who was that?
I get blamed for every single thing in this.
Because you look guilty.
Macy, that was the
We'll have this discussion later. Okay. Moving on. Table. Got it? Percentages. Relative. So we go from just the numbers to now putting them as percentages. Got
We
it?
have to make a table.
You will have to make tables. Yes. Correct. Okay. All right, here we go. Francesca. I'm going to make my table over here. Francesca asks, be quiet. Francesca asks a random sample of 140 upperclassmen at her high school whether they prefer eating breakfast at home or at school. So we have juniors and seniors versus
yes or no.
home or school breakfast, right? Okay, so let's see. They do. Put your table here. Put your table over here.
Need a table.
I don't care. We're not going to use our table. We have home. We have school. Write this in the margins. Okay?
Literally the same thing.
I don't care.
Does it matter if you put
Senior,
the school on the top or the left?
junior. It doesn't matter. No. Good question. Did you hear what he just asked?
Yes.
Could you flip them? Yes, you can. This is a total row. This is a total row. Okay. All right. So we asked 140 upperclassmen. Where does 140 go?
Total.
Total at the bottom, right? Okay. She finds that 55 juniors and 23 seniors prefer eating at home. So 55 juniors, 23 seniors are home, right? Okay. 12 juniors and 50 seniors prefer at school. Okay. So now we can figure out our totals. What's our total number of seniors in that class? 73. Total juniors? 67. Total number of people that prefer at home? 78. Prefer at school? 62. And those should add up to be 140. Okay. Out of these, the pink ones are called what? Joint frequencies. The red ones are called marginal frequencies. They are in the margin. Got it? Okay. So we have our frequency table. Now they want us to find a relative frequency table. It's going to look exactly the same. So here's my relative frequency table. I'm going to change these to percentages. That's all I do. Okay, so I still have home, school, junior, senior, total. Okay, 23, I'm going to take it though, and I'm going to divide by how much?
140.
Everything's divided by 140. Okay, so do these. 23 divided by 140. I know this is 100%. Help me out. 16.4%. Okay, keep going. Somebody pick one.
50 over 140 is 35.7.
Okay.
What you do, junior and senior?
And then the next one is 52.1.
Oh. Whoops, hold on. Whoop. Senior, junior. Okay.
First total
55.1 over here.
52.1.
52.1, thank you. Now, really, honestly, this guy should be these two added together,
Yep.
right? Okay, but whatever, it's fine.
140 is 39.3.
Okay. Got it?
And then 12 over 140 is 8.6.
Okay.
And then the one next to it is 47.9.
Okay.
And then the one,
55.7.
good job, one.
Okay.
And 44.3.
And 44.3. Perfect. Okay, good? Yes?
You stop it.
Not hard, right? You can flip those around, whatever. You're just doing everything is divided by 140. What?
Do you have to put those in a percent?
Yes.
You have to make the two tables.
Well, yeah, put it as a percentage. It's better to read as a percentage. Okay? All right, good? Okay. This is going to be the hard part. You remember in the last homework assignment, or like the last section, where we talked about independent versus dependent, right? Like things that were independent, things that were dependent, right? Okay. So here's the deal. I'm going to go down and we're going to talk about this thing, and we're going to talk about high school, college freshmen is 1 versus high school seniors. Okay. So college freshmen, high school seniors. Okay. And we have, what's EDM?
Black.
Electronics, dance, music, or hip hop, right?
Oh, no, that's black.
Okay? So, here's what's going to happen. We are looking at this table. We surveyed 240 total people, right? more college freshmen than high school seniors. That doesn't matter, right? Okay, but 240 total is how much we surveyed, okay? What we want to see is whether these two things are independent versus dependent, okay? Like, if it's independent, that means your age is not going to determine your likelihood of choosing EDM versus hip hop, right? Like, just because you're a college freshman doesn't mean you're more predisposed to choose hip hop. Does that make sense? Right? Okay? That would be independent, okay? A scenario of when this would be dependent. Let's talk about your age, and let's talk about the number of people in each grade that's participating in Husker Harvest Days. Is that dependent upon your age? Why? In Blue Hill, freshmen are not allowed to go, right? So that is something that depends. How do you determine from the table whether it's independent or dependent? Like, how do I know that maybe if you are a college freshman, you are more likely to choose hip hop than a high school senior? Okay, here's how we figure this out. So we go down, we look at this table right here, right? This is just the numbers. This is just the regular frequency table. Then we go down to the joint frequency table. Let's do this percentages again. Sorry, let's do that. What is 100 over 240, all of these? 41.7%, okay? Keep going to the right. 44.6, okay?
30 filled out below.
No, it's not. That's not the right table. Well, not quite. Just, yeah, keep going. Okay, what?
86.2.
Okay, got it.
6.7.
6.7%, okay?
7.1.
7.1,
Yeah. 13.8.
okay?
48.3.
I could, 48.3, that's a rounding error, okay? Or not a rounding error, but like it's rounded differently, but whatever, it's fine. What?
51.7.
Okay? And 100%. Okay, all right. This is my relative frequency table, just given off the stuff above. Okay, here's how you determine whether or not they are dependent versus independent. Ready? Okay, so what I'm going to do is I'm going to start with, I'm going to create this table, and I have freshman and I have senior, right? High school freshman, or college freshman, high school senior, whatever, right? And I've got this going on. And here's my table. I've got EDM and I've got hip hop, okay? My totals over here were 86.2, 13.8, and 100. Over here, they were 51.7, 48.3. Okay, are you ready? I'm taking my totals. These are my marginal frequencies. Here's how you determine whether independent or dependent. Got it? Okay, I'm going to move this back to a decimal, so this is 0.862, right? And this is 0.483, right? And what I'm going to do is I'm going to multiply these two together, those decimals, and it should end up being this number, right? Whoop. Right there? Okay, if you multiply those two together, 0.483 and 0.862, what is it?
0.416.
0.416. Okay,
Wow.
yeah? All right, now I'm going to do the same thing again. I'm going to take 0.862 and I'm going to multiply by 0.517. And that should go where? Right here, right?
0.4.
Okay, yeah, you're just, what is it?
0.446.
0.446. Okay, now I'm going to do 0.483 times 0.138, right? And that should go here.
0.066.
0.067, right? And then I'm going to do this one and this one multiply together, and that's going to give me this one, right? And that is how much? 0.071. Okay, this is what they should be. This is how the table should work. If these two things are not related, meaning they're independent of one another, right? This is what the table should look like. Is that what the table does look like? Is that what my other numbers inside of here are?
Yeah.
So that means that it's independent. It does not matter how old you are not predisposed to choosing one or the other. Does that make sense? If these joint frequencies don't match these over here after you do the whole multiply, put them in the right spot, then they are dependent. The one variable does depend on the other one, kind of like Husker Harvest Days does depend on your age, right? Okay? So these will not match over there if they are dependent. Got it? If one depends on the other. Make sense? Okay. This one does, so they are independent. Therefore, musical preference for these responses are independent of grade level. Got it? Independent. Yes? Do we understand how this works? Okay. What is this one?
Skip.
No, I like this one. Let's do this. All right, example 3. Conditional probability with a two-way frequency table. You can use joint and marginal relative frequencies to approximate conditional probabilities. All right. Abu, whoever that name is, posts a question to an online forum or about the originality of posts to the site of the 55 respondents who posted. 55 is my total number, right? I'm going to put those next to the percentages. 27 27 photos and 15 photos were not original content. 27 photos and 15 videos were not original content. Do you see where I put that?
Yeah.
Okay. All right. While 3 photos and 10 videos were original content. 3 photos and 10 videos were original content. How many total videos were there? 25?
Yes.
How many total photos were there? 30. How many total not original content were there? 42. How many total original content? 13, right? Okay. So they get these percentages by doing the 15 divided by 55, 10 divided by 55, this guy divided by 55, this guy divided by 55, right?
I don't know.
Okay, somebody give me these numbers.
Whatever norm.
Total should be like, I don't know, 45.5 over here. Is that true? Ish. Okay, what are some of these other ones? What's 27 over 55?
49.1.
49.1. Okay, go to the next one over. This should be like 76.4-ish. Okay, keep going.
5.5.
5.5 here. Okay, next. 30 over 55. Oh, wait, I can do that. This should be 54.6. This guy should be 23.7. Yeah, something like that? No? Is that not quite right? It is? Okay, so there's that. I just added these together, right, to get the total thing. Yeah, got it? Yeah? Okay. All right, last question. Find the probability. Here we go. Find the probability. This is a question right here. Listen one last time. Shh. Find the probability that a viral meme on the forum is not original content given that it is a photo. Okay, not original content given that it's a photo. Now I'm not talking about all 55 of them. I'm only talking about the photos. How many are photos? 30. So 30 is my bottom number, right? Okay, I'm only talking about the photos. Of those photos, these photos right here, which ones were not original content? 27 is my top number.
90%.
Okay, you see that? Photos, not original content, 27. Okay, 27 over 30, whatever that is. We could have also done the percentage over top of each other, right? Instead of doing 30, I could have done 54.6% on the bottom and 49.1% on the top. This is going to end up being the same as that. Got it? So I can use the original numbers or I can use the percentages, doesn't matter, right? Okay? But given whatever, that determines my new bottom number. Got it? Whatever that ends up being. 90.1%, they say. Good? Make sense? All right, lots of things going on. If you want help, let's help set up like number 1. Organize your two-way frequency table.
Yeah, let's do number 3. I think we
What are you talking about?
Yeah.
What?
Yeah.
Yeah. Please.
Because number 3 has more words.
Please.
We're not
All right, whatever. A ride-sharing company surveys 2,000 of its customers who are college students. They survey and ask the following 2 questions. Are you attending college in or out of state? That's 2 things. Do you visit home more than 4 times this school year? More than 4, less than 4, right? Okay, so let's do our frequency table. What do you want to put on the top? Besides your total row. In or out? Okay. And then On the left? More than 4 or less than 4, right? Can I just put greater than 4 or less than 4, right? Okay, now we just plug the numbers in. Oh, 2,000. Right? They told me 2,000 to begin with. Where does that go?
The total.
Total, right? 2,000 goes there. The survey finds that of the 1260 students who attend in-state college, where does 1260 go? Total in-state is 1260. Okay, do you see where I'm putting these numbers? 928 of those visited home more than 4 times. Where does 928 go? The top left. Right? 928 goes there. Okay? Can we figure out what this one is?
Yeah.
How?
Subtraction.
Subtract 30. What is it? What?
This isn't the problem, 332.
It does.
Visited
What?
home, 4,
Oh.
8.
Oh, and 332 visited home lesson. Okay, whatever. Of the 740 students who are out of state college, where does 740 go?
Total out.
Total bottom 740. Okay. 118 visited home more than 4 times. And 662 visited less than 4 times. So 6 what? 22. Thank you. 22. So this is, I don't know, 6, carry the 1, 4, 1046. Yeah. 4, 5, 9. 954. Okay, that's what your table looks like. Organize the response in a two-way frequency table. Done. Construct a relative frequency table. We're going to do the same thing again, but do your percentages. That's why this is kind of tedious. Okay. Greater than 4, less than 4, total. In, out, total. Okay. Can you take it from here? Yeah?
No.
No. Okay, do your percentages and yeah, all the things. Okay, and then answer part C. Okay? Beautiful? Great.